Okay, hi everybody. Welcome to my talk here about mastering challenges of cloud-native architectures with Spring. Actually, this talk I created like 5 years ago, and it's really interesting that it's still so relevant. My name is Timo Salm, and I'm a pre-sales specialist for Broadcom, known as actually the vendor of Spring after the acquisition of VMware and Pivotal, and also, for example, RabbitMQ. So we have most of the open source contributors. A lot of them you may have seen here at the conference, talking about Spring AI and all the exciting stuff coming up with Spring Framework 7 and Spring Boot 4. In my role, I'm actually helping our customers solving their problems with our open source and commercial products. Here you can see a typical modern architecture, so microservices. Why microservices? Not because it's the best architecture. It's just because of the fact that it's one of the most complex architectures, because you have a lot of, in those distributed systems, a lot of interactions with other services, and yeah, if one of those services fail, if you're not have a proper a strategy for failures, etc., you have cascading failures, and therefore, usually, for example, you don't know where the error is, and it's really hard to debug, but also the experience for the end users is usually not that great. So with this sample application I created here, we have 3 services. It's a typical example for a supply chain application. All of them are actually built with Spring Boot, and you can create orders, and the order, so if there's a new order, it will be validated based on the product service. You can see that's a synchronous actually a REST call from the order service to the product service. We also, as I would say in most of the cases, this should be the case for microservices, you have asynchronous communication with the shipping service, and as soon as an order is created, it will be stored in the database. A message will be sent via, in this case, RabbitMQ to the shipping service, and after the order is shipped, after some amount or configure amount of time, an event will be sent back that the order is shipped. So a really basic example, but you can see a lot of the challenges those architectures actually bring. And it's like, even if that's about that's a microservice example, you can also actually use a lot of those patterns that I will show you with, for example, modular monoliths or other architectures. At the end of that, so all those services, I started with Spring Boot because of the fact that it really provides a lot of developer productivity with all this auto configuration, for example. And Spring Boot and also most of the projects for integration of tools, etc., they actually rely on the core principles and functionality of the Spring framework. Like, for example, the inversion of control container, like an environment abstraction, or also resource loading. Last but not least, we have Spring Cloud here. So that's actually more or less the project for microservices or distributed application, providing a lot of implementations for patterns that we will see. So really challenges you face with microservices, and then Spring Cloud provides the implementation how to resolve that from a implementation client side, but also different components that actually are required to mitigate those challenges. What's the best way to actually identify the challenges we may face with our application? Actually, it's the 12-factor app methodology. So how many of you are aware of the 12-factor app methodology? Okay, so a lot of the people, some not. This is good, because otherwise we could just spend the time in the sun. Actually, so that's a really, I would say, old framework for, at the end, a recommendation of best practices for modern distributed applications. It was created 2012. There are newer versions available, which I will also go through, but at the end it really helped us to actually identify the challenges we may face with our distributed application, as that also monolithic applications, cloud-native applications at the end. And if we have a look at the first factors here. The first one is code base is tracked in revision control. Hopefully, most of the production applications at the enterprises, they are now tracked in a Git or something like that. So that's something, hopefully, as that, we don't have to talk too much about it. The sample I provide here, so I will push the latest latest version actually during the weekend, so you can have a look at it. I have one repository, a mono repository, so all my microservices and components are actually here. You can try it out locally on Docker. At the end, there are a lot of projects, and also even if it's like a mono-repository, just a recommendation. I'm not a fan of it, but there is like some debate on it, whether it's good or not. Big companies, tech companies are using mono-repositories, but they have the tooling to do that, because usually if like you have a microservice architecture based on Conway's law, that reflects your organization, which means that you have a lot of services. Usually you have a lot of teams working on the code base, and then if you have one repository, it could in a way you reduce the developer productivity, because you have to, with merges, etc. It takes a lot of time if you want to push new features. So always think about whether it doesn't make sense maybe to, if you have microservice, create separate version repositories for that. Let's go back. The next one is about dependencies. So actually you should really explicitly declare those dependencies, so with versions, patch versions, etc. Because otherwise you, after maybe 2 weeks, push the new feature, it's not working, and you're not sure whether it's related to a dependency update or whether it's related to the code. And that's something also, like there's standards in Java. We have Gradle, we have Maven from the past, we have Ant that actually resolve that for you. We have those really great bill of material, or all the starters for Spring Boot that manage all the versions for you, that they are compatible. So with minimal effort, you get this out of the box, more or less, especially if you start at Spring.io to create your new projects. For those that are not aware of what I'm talking about, at the end it's like, in the project, there's like this pom.xml, so for Maven, defining all the dependencies. Here I have a parent project, which is defining the Spring Boot version I'm using. And then in all those dependent services or sub-projects, I have like all my dependencies, and you don't see any version numbers because of the fact, as said, they are managed by the Spring Boot starter version or the parent, and therefore you don't have to care about all of the dependencies that are continuously checked whether they are compatible. About the versions, for sure there are some, maybe from third-party open source vendors, that you are not able, or that are not managed in this bill of material, then you have to define a version. Okay, so that's also something I guess most of the people already have, so let's talk about the third factor. And the third factor is actually about not storing your configuration with the code, or actually separating that, because of the fact that you want to deploy your application across different environments, and you don't want to, for like changing those environments, have different jar files, etc., different source code. For sure, the environment abstraction of Spring Framework really helps you with that, because there you have this add profile annotation, so you can switch implementations, for example, for different databases, using an in-memory database for the integration testing, and then on production or test environments, you use, for example, PostgreSQL. But then it's like, it's still not enough, because you need a way to actually provide this configuration to your application. And if it's packaged together in a jar file, that's a lot of effort, even you have different ones for different environments. Also, like if you just have them on the file system, it's also an effort. And for that, actually, Spring Cloud provides a solution, which is called Spring Cloud Config. And the Spring Cloud Config consists of 2 solutions. So we have a server component, which is actually fetching the configurations from different sources, like, for example, Git. So you can store your Git, your configuration for your applications for different environments in Git. And then we have a client that's actually fetching the information from the config server. And if you don't know how like configuration works in Spring, so it's like there's a hierarchy of different configuration sources. So they have some priority. And for example, with this Spring Cloud config, this has a higher priority than your application YAML files in the code. The highest abstraction usually are environment variables with which you can override it. But yeah, with that you can really override all this configuration for the specific environments. And based on patterns like folders or names in the YAML files, it will then detect the right actually configuration for a particular service and also profile. If you look how we can implement that. So let's go to the product service here as an example. You can see I have one dependency here, the config starter, which is actually implementing all this functionality to reach out to this config server and pull the latest configuration for this service in a specific environment for a specific version. Then we have this config server component. That's also something I can easily build with Spring Boot. Just go to start.spring.io and define the config server. The only thing I have to do here is some basic configuration, like where your sources are. Those can be multiple. In my case, it's just the same Git repository I just showed you in the externalized configuration folder. And that's also something we can have a closer look at here. So if you go to product service, we can see that's the YAML file that's in my Git repository. This will be fetched. I have a name of product lists, some additional configuration for Spring security, etc. So everything that's more or less dependent on specific environments. With that server, so how to enable it, I have this dependency, and then I have this enable config server annotation. That's it. So it's like all the functionality is there for sure. You can extend it, you can configure security, etc. But it's really a basic setup to get started. From a usage perspective, that's it. So the only thing I have to configure is where's my config server. You can see this here. And you can also see I have config import, config server, and then I have the URL to the config server, which usually, so the default is like 8888. You could also, if it's like not that important that you reach out, or if like the config server is not available, you still want to have the application running, you can also add an optional prefix, so optional. And then it would not fail, start up the service, it would just not be able to reach out and use the default configuration. Another really great thing about it is because it's like, yeah, so I have this config server, I have this configuration which will be fetched when the application starts. But yeah, what if I change like critical components, etc., in the configuration? What will happen? Nothing. Because of the fact it will not continuously fetch and change some stuff. At the end, what you have to do is like either restart the application, which is sometimes not the best, but if it's not like at the beginning of the startup process and a really important bean or component, what you can do, so there's something in Spring called the refresh scope annotation. So I have my bean here. So the product application service, I have this add refresh scope annotation. You can see here I'm actually fetching this configuration value for the product names. And if I now, for example, go to my or try to call my code. So first, let's get a new access token, and then I do curl product service. Hopefully I will find it. Here it is. That's the second one, but it's also something I need. 1 second. Curl gateway URL product service. You can see, so those are the ones I have configured in my Git repository. If I now go to my Git repository here, so my external configuration, and add something, like, for example, then the application catalog. Save it, I go back to my terminal, do a git commit and push. And if I now run like this curl, it's still returning those 3 services. But if I now actually, there's an actuator endpoint called refresh, which you can enable. And if I run a post here, in best case, if my config server was already able to fetch this new change, and I run it again, you can see there's tons of application catalog. So without restarting my application, I'm able to change the configuration of beans, which is really amazing from my perspective. Okay, so that's it about Spring Cloud config. Let's have a look. You can see the component here. So for sure, an additional component we have to manage in a way. The next 2 are about baking service. So the factor 4 is about that they have to be actually treated as attached resources, which means that if like there's a database failure or something like that, you don't have to change the source code. You can just, in a way, from the backup, create a new database, attach it, and that's it, without source code changes. And as you saw, the config server will help with that. Because then we don't have to, even if it's like the jar is bundled with the configuration, we don't have to rebuild it with additional configuration or something like that. And on the other side, it's another one about the processes, and this is really important. This is why those baking services are more important than ever, because of the fact that modern applications, they are stateless. So in the past, in those big virtual machines, usually the applications are stateful, which means that a lot of necessary information was stored also on the file system, etc. That's different in modern applications, and this has several benefits, like for example being able to horizontal scale, high availability across different environment regions, etc. And this is also, or actually with that, those baking services to persist any data that's required is more and more important, and also those baking services, if you have more of them and the applications rely more on them, other services, etc., it's necessary to make them at the end as robust as possible. And for that, I will now introduce several additional capabilities to handle fail-off, for example, or because of timeouts, to reaching out to those services. And even if it's the database, they get faster and faster, as you know, but if you compare it to a current database that's really famous, which is more or less not deterministic and really slow, so like large language models in a way, that's something really relevant still, because it's like you need those retry patterns, etc., for example, if you run in a timeout, or also if the result is because of hallucinations, is not what you would expect. And the first one is here is load balancing. Some of you may say, yeah, we are running on Kubernetes, we have services, that's amazing, they do some load balancing, I have a DNS that is actually handling that for me, so I just call this DNS name of the service, and one of my few instances will actually get the request. At the end, that's true. The thing is that services in Kubernetes regarding load balancing are very limited, which means that in a lot of cases they're just returning one IP, if it's not like a headless service specific configured. And with this one IP, if you have especially some DNS caching, your application or this instance will always reach out to this one IP instead of doing something like round robin, and so really distributing the requests. And on Kubernetes, for sure, there are other solutions available for that, like, for example, your ingress gateway or ingress controller usually has better load balancing. But also with Spring, there is a Spring Cloud load balancer, so a solution to really do client-side load balancing. And it's really well integrated into REST template, REST client, and web client. If we have a look how that looks like, so from the config server, as said, I have a synchronous request to the product service. If we open that, we can see that, so here is the request. It looks a little bit complex because of this circuit breaker I will introduce in a second, but yet I'm just using the REST template. For sure, there are now also a REST client available, which is a little bit more modern from the API, but I'm using REST template here because most of the people are still using REST template, so nothing special. But if we have a look at how I create this instance of the REST template in the configuration, we can see that I just added an add load balanced annotation here, and that's it. So I have the dependency, Spring Cloud a load balancer, I have this add load balance annotation, and with that we have this advanced load balancing capabilities from a client side to, for example, those other microservices. And that's also something here. It's really I declared it, so I don't want to have it. But some other solutions I will also show later, they are just doing that under the hood for you with a minimal, instead of HTTP, using a LB : / as a protocol. So there it's a lot more hidden than, for example, here. So that's about load balancing. You can see it here to the microservice, product microservice call. I added it. Next thing is about caching. Even if it's we have those nice applications, we have horizontal scaling, in best case a lot of performance, we still have in a lot of cases traditional big databases. They are often a little bit slow. There are other solutions for that, like for example Redis, etc., with which you can really improve the performance with caching. And that's something Spring supports with a really nice abstraction. So that's part of the Spring framework. All those providers, they are actually then implemented by different starters, etc. For example, Redis, HA cache, we can do the caching on the memory and also file system. So from my perspective, probably not the best for a distributed application, but it's supported. But if you have an external cache like Redis, that's more or less the solution. You can see we also have a Tanzu solution here. So from Broadcom, which is called Gemfire, similar capabilities than Redis at the end. How we implement it? As said, so that's like the core that's in the framework. So therefore, we don't need an annotation or a dependency for the support of like the annotations, etc. The only thing we need is we have to configure here start a cache for this auto configuration of Redis at the end as a cache backend. And then how you actually are used to it from Spring, it's very, very easy to actually add those caching capabilities, because there's one annotation first to enable it, so enable caching, and then on the product service, so this REST call, I just at the method level, I add cacheable and give it the name of the cache. Because it's distributed, so it's in Redis. For example, if I save something in the cache and then it would actually give the cache a note that I created a new item, so that the cache will be deleted more or less. That's then something available to all the other microservices also. So they will not cache it and wait until like the cache expired. They also, with this external cache, then notified about the change. If I want to do it on the database level, it looks very similar. So here I have my repository. Because of the fact I'm using JPA repository, same with JDBC repository, usually for those basic methods, I don't have to define the methods, because it's like this is how those repositories work. But because of the fact that I want to add those annotations, I have to override them to add those annotations. So here to find all the orders or find by ID, so that's order, because that's then cache per ID. And here you can see if I save that, I for sure want to delete more or less or evict the cache, and this is something I can then do here. So that's it more or less. So really easy to implement that. And yeah, if you have a slow database, not sure how well that works for your AI use cases, because usually you don't ask the same question all the time. For sure, if you're like hiding or using AI for specific tasks and not like having a chatbot, then it could be different, and then maybe you can cache the answers also, like, because you know how slow those models are, and with that you can really improve the experience for the users. That's about caching. And the last thing I want to introduce here is about circuit breaking. At the end, it's like you always have to, so that your services fail, that they are not reliable, that they time out, etc. That's something you have to expect in a way. And this is something you have to handle. The easiest way, and this is also something heavily used within Spring AI, is retry. So Spring retry is the name of this dependency. You define like if something fails, if there's a timeout, how often, and after which time it should retry to call this service. A circuit breaker goes one step further. Even it's also like you can have different implementations, like also Spring retry, because what it does is you can define retries, but you can also define fallbacks. So if you have, for example, a big dashboard with a lot of information of your car or whatever, and there's something that's not really required for the user, it would make a lot of sense to have a fallback. So that, for example, then on the end user view, it's like there's tile currently not available, something like that. And that's something you would implement with the circuit breaker. The idea is the circuit breaker waits also for a specific amount of time until it calls the service. So all the requests are getting in for this time. They get this fallback response, and this helps with actually the service that you're calling, that it can recover. Because it's like if there are too many or there's a lot of demand, and because of that the timeout grows and grows, and if you still like try to get the information from the service, even if it times out, it will never recover. And therefore the circuit breaker helps with that, because it provides a default, and then after some time hopefully the service is recovered. How you implement that? It's a little bit more complex here. I I also implemented in the auto service for this product service call. So we first have to add this dependency, in this case with the implementation. So circuit breaker, we use resilience force J here. Then actually we have to, if we go to the application, let's see, I think here I have some additional configuration which is for like authorization, etc. Because the problem is that this the circuit breaker is running in a different process. So it's like encapsulating the call, and therefore some of the stuff gets a little bit more complex. If the usage is also like, from a code perspective, maybe not that nice than those annotations. So if we have a look at our product service, we can see that we have the circuit breaker factory we created for a specific circuit breaker, and then we run our functionality that we like to have, and then we have like this callback, which is in this case, just an empty list of products. That's just an example, but again, it's like this is how you can implement those fallbacks, and you can define a lot configuration there. So like how long it should wait, how often it should retry, etc. So that's about circuit breaking. And with that, we tried a lot actually to make this connection to our product service a lot more reliable and robust. The next thing is about port binding. In the past, in a lot of cases, like the dependencies to a database, they were like an IP actually to reach out, which is a huge problem. As that, if it's like you want to have them attachable so that you can easily change them, etc., and especially in a world where we have multiple instances, that's really hard actually to do that. So it's a lot better to have, for example, DNS, where you can just reach out to a specific name, and then in the background there will be like the IPs, and your call will be directed to the right instance. I said it's something that Kubernetes supports, and for that also there is a library which is called Spring Cloud Kubernetes, which does all this like service registry, so that's how we call it, sort of service discovery for you on Kubernetes. This Spring Cloud Kubernetes also helps you with actually those config server, because it's like the native solution for configuration in Kubernetes is a config map, and actually that's also something supported with this Spring Cloud Kubernetes dependency. For non-Kubernetes environments, and it's still a better benefit to think about whether you should use it or not, because of the fact it's like if you use only those Kubernetes native features, you are in a way locked in Kubernetes, which means that you change to a higher abstraction, for example, there's some effort involved to change that, and there are several other implementations for those so-called service registries available. For example, Consul from Consul, for example, from HashiCorp, or also Eureka, for which we have a Spring Starter, and that's something. So how I implement it here to be able to really run this on the laptop. So we have first this service registry. It's also like the config server. It's just like this Netflix Eureka server component. You have some minimal configuration, like enable Eureka server, and that's it from the server side. So also really basic functionality. And then on the client side, so what you need is like that the client, that they reach out to the service registry as soon as they are started, and also if they are shut down, to actually register them, that other services can use them or have the IPs of those services and can reach out. And that's then something you, for example, implement like this. So you first add the dependency, in this case, Cloud Starter Netflix Eureka client. You have the configuration for that, which I have in my external configuration because it's specific to the environment maybe. So here you can see I just defined the service registry, and that's it. With that, it's more or less hidden. The question is, what can I do with it? At the end, I can, instead of like relying on the DNS of, for example, Kubernetes, or if you don't have solutions like that, IPs, etc., you can easily call those services via just their names, and the name is coming from like the Spring application name. So if we go to resources here, you can see there is the Spring application name, auto service. that is actually used as a name, and same for product service. And if I then have a look at the configuration for the order service, where I call this REST service, you can see that I just have this product minus service. And with that, the service registry has all the IPs. It's forwarding them to my client if it tries to reach out to the service ID, and with all the IPs so that the load balancing also works with this at load balancer annotation. So that's helping us with the port binding. You can see it's an additional component you have to manage. If you're using Kubernetes, maybe you don't. But here, as I said, for this really Spring architecture that you can deploy everywhere, that's necessary. Next factor is about concurrency. At the end, it's like we talked about, that modern applications, they are stateless. They don't store any. For sure, it's possible to interact with the file system and maybe store some file there, but it should be stateless. And therefore, the question is also how you scale. So in best scale, or in the past, in virtual machines, you scaled vertically, which means you added a lot more resources to it. In the cloud-native world, you're able to scale horizontally, which not only helps with high availability, because you have a lot of instances, and one fails, there's another one. It also helps you to save a lot of money, because some platforms, like, for example, Knative, which is a component for Kubernetes, open source component, it can scale to 0. Also services like AWS Lambda, etc., they can scale to 0. And with that, you don't actually invest, or it doesn't cost any money as long as there is no demand, which is really great for applications that don't have the same demand all the time. Maybe at weekends, no one is working with them. And also, like, if you have a lot of change in demand. So let's say there is a concert of a specific band, you can, or I think you experienced that all, you go to the website and it's not available anymore because of the demand. It was not able to handle the demand. And that's something where this concurrency is really important. And also, like, having solutions that can auto-scale. The thing about it is, the next factor is about disposability. For the robustness, you need fast startup times, especially if you scale to 0, because otherwise you have to provision for demand. So, okay, there's something happening at the weekend, let's provision more services. And you also need this graceful shutdown, for example, for the service registry, to unregister yourself. Otherwise, a client will call you even if there's no application available anymore. And you may have seen some talks about how to resolve that with Spring, because as you know, Java is maybe not the best, or not known as the best technology for fast startup times. So if your application starts in 15 seconds, that may be too late for the clients to wait. So they time out, especially in the microservice application, where you have cascading calls. At the end, we have some amazing new technologies here. So some are there for years, some are really new. There are several talks available from my colleagues, also from Oracle. The first one is, for example, GraalVM native images, where you can really massively reduce the startup time and also memory consumption, which also helps, because memory, every megabyte of memory, if you scale to 100 or 1,000 different containers, is a lot of money you can save. There's more. There's, for example, Project Crack, which is, from my perspective, has some limitations. Because of the fact that you more or less make a complete snapshot from the memory, which means all credentials, etc., are also in there. And you have to, because of that, usually do the snapshot in the environment, in the runtime environment. So something also from a Spring perspective we are supporting, but yeah, we are more focusing on other solutions. And the next ones are those we are currently heavily focusing on. So it's like class data sharing is there for years. It's really robust, but it helps you to reduce the startup time for some amount, like, let's say 30%, something like that. And there are new capabilities available with JDK 24, and even more improvements with JDK 25 and later. And so this, and that's more or less the new version of class data sharing, is called AOT cache. And the project with all those enhancements regarding this AOT cache is called Project Layton, so was also introduced at the keynote. Downside of that is you have to update to Spring Framework 6 and Spring Boot 3 to get those benefits. And if we have a look at it, so here it's just like an application I ran on my computer for several different technologies, and you can see those differences. And one of those differences, if you're like, yeah, so we need some time to upgrade, but let's start small and do a JDK update, you can see that you already, for example, with a change from 1.8 to 21, you get 10% startup improvement. Also memory improvement, because of the fact that, for example, the garbage collection was heavily improved. The next thing is, what is really recommended for production nowadays, is to unpack your fat jar in a container, etc., where it runs, which also gives you actually some enhancement. The biggest improvement is something you will get, or you will get with GraalVM, and this will be probably always the case until there's a new technology available, because of the fact that it's like really compiling your application to native code. So something that is done for improvements with a just-in-time compiler, usually, so those code that will be heavily executed or that will be also compiled in native code, and with a GraalVM, the complete application is like native code running on a specific operating system. And therefore, you have this dramatic like change in startup time and also memory consumption, because a lot of these components, etc., and you know from the Java world, so this JVM, etc., is not available anymore. The core functionality, it's called in a substrate VM, is part of it, but actually, yeah, there's no JVM anymore, so that's eliminated, and therefore you have these improvements. The nice thing is with AOT. With the AOT cache, actually, and code compilation, that's something not available yet, only in like the early access. You can also heavily reduce the startup time, like here 65%, for example, and also get some memory change already or benefits. At the end, it's like that's something, currently there's no focus on memory change, but that's something they have on the plan or on the radar, so in further improvements, probably you will get that. The nice thing about that is you don't have to change usually anything regarding your code. So it's like you will get access to those improvements just by upgrading to newer versions. GraalVM is different because you cannot use all those dynamic features you maybe rely on, so reflection, etc. That's something you can mitigate if you know what you want to dynamically run later, but because of the fact it's compiled before the runtime, it only compiles the code you make it aware of. Here's a nice technology comparison, I think, which is also online from my colleague Sebastian Deleuze, who is the lead for this runtime efficiency topics. And yeah, you can see this is also why we heavily invest in this AOT cache capabilities. You have minimal trade-offs and still like a lot of improvements that are relevant for those things. Next thing, depth and broad parity. I think all of you have heard of containers. They make our life really easy. You can actually test your application in the same environment more or less than in production. Also with tools like test containers, for example, you can run integration tests and against common databases, etc. So that really helps us. How many of you actually have a Docker image like that or Docker file like that to build their container image? Okay. So 4 lines of code and my application is running in a container. That's amazing. Yeah, despite the fact it's JDK 8. This is how a more advanced container image looks like. So we have first a multi-stage build. So because of the fact that the JDK has an additional attack vector, it's also bigger. We first actually use the JDK to maybe build our application, or in this case, run this layer tools extract mode to actually extract our application to different layers, and with that we have benefits of caching of containers, which is really relevant not only for your computer, because of this caching you have less disk used for those frequent or later builds. It's also like for Kubernetes really relevant, because otherwise every time you update your application it has to pull the full container image with these layers. If you only change the business code, it only have to push the layer of the business code to all the Kubernetes nodes. You can see like the version that's used is different, etc. So at the end, what's the conclusion about it? It's not easy to build a proper Docker file. So that's just the case. And there's a lot more you can do, as we just heard about. Okay, you can unpack the deployment, etc. And therefore, we have a technology which is called cloud-native Buildpacks, which is coming from Pivotal, so which I joined before the acquisition of VMware and Broadcom, and Heroku. And the idea is that the Buildpacks, they detect what's required to build a container image from the source code. We have run images, etc. And the big benefit of all these tools is that you just run them without having to know too much about how the container image looks like. There are a lot of best practices from us, from the Spring team involved. And actually, every time you run it, it will check, are there new dependencies available? So new middleware, new Tomcat, for example, new JRE available. If yes, it will pull that and push that. So if you deploy your application every few days, you will always get the latest and greatest regarding like the rest of the stack. For sure, you have to update your Spring application yourself. Those capabilities, they are part of actually Spring. So Spring provides via a plugin those capabilities out of the box. So all of you that are like using Spring Boot up to or from version 3.2, you have those capabilities. So you can just call Spring Boot build image, and a container image will be built on your computer. If for sure you have like a container runtime, Docker runtime, something like that. Otherwise, in your CI/CD system, with best practices in mind, and always up to date if you run that. There's also a solution available which we contributed, which is called KPack, which is doing that in a Kubernetes cluster for you. The big benefit is that the updates are in the hand of the operators, which means if there's a new update for the operating system in this Kubernetes cluster available, it will rebuild all or rebase all the container images that are there, and based on the CI/CD pipeline, you can then automatically push it to the next test environment. And with that, you don't have to care about updates of the middleware and the entire stack, despite the source code. That's your job. Okay, two more. Actually, logs. For sure, in distributed system, that's a special challenge because you cannot just go to. You can go to specific instances, but it's a lot of effort to find the right instance, service, etc. So you need some log aggregation. That's something usually handled by the platform. For sure, with Spring, we have all the support we need. But as I said, usually it's something of the platform. Also, the last one here is a little bit maybe outdated. That's usually about, okay, how you can access the production environment. Some of my customers, they are not even allowed. So there are no people that have any access to the production. It's only like the CI/CD, etc. So that's maybe a little bit outdated. And so that's it regarding the 12 factors. I said they are 12 years old. A few years later, there was a new version published. And this version is available, so you can download it. If you are interested in those factors, read about it. In addition, so there are 3 more factors, but it's also like really describing them really well and what's changed. So a little bit an update, I would say. Just as some information, there's currently a working group working on a new version of that, which is open source. If you search for 12-factor GitHub, you can find that. Trying to find what's current, what changed, how they can make them better, and also maybe whether there are new factors. The first one is telemetry, and at the end it's like because of the fact that developers or application teams are responsible for the full lifecycle of the application nowadays. So they are not just like throwing the source code or the jar file, var file, together with the operational manual to the operators. They need observability, because it doesn't mean that this responsibility that they have to go to the Kubernetes cluster and do debugging. It just means that they need good observability tools to see whether the application behaves like it should be. And one of those, so in addition to, for example, logs and metrics, one of the most important capabilities here, especially for distributed systems, is distributed tracing. That's also something the Spring Boot actuator, which you should add to any application because it provides a lot of production features. Also, there's a new metric endpoint where you can directly fetch the memory consumption and startup time of your application, which is really great. It provides like the dependency injection auto configuration for micrometer tracing. Micrometer is actually the abstraction that Spring is using for metrics and also observability in general. And because of the fact that it's an abstraction layer, then you have to define to which format you want to transform that. So, for example, open telemetry protocol or Brave, and then to which solution you want to export that. And that's also something really easy to do. Just go to one of the POM files here, order service, for example, and there we can see that I have, if I'm able to find it, let's see, test, somewhere in the dependencies. Here. So just like those two dependencies, then you for sure have to configure a system to which those should be exported, and then you can have a look at like those graphs, so how the flow is. And also if there's an error, usually you have part of this exception in like this information and can easily see where the exception happened in which service. Okay, what else? So we're reaching the end of the talk, but actually there's more. And one is API first. So the idea of this factor is that you should design the API first before you begin with actually the implementation, which means that you first, before you start implementing all the stuff, you first ask the consumers of your API or stakeholders or users in general how the API should look like, so discuss with them what they need, etc., and then you should implement it. But there's for sure more, because as you know, nowadays everything is API. So it's like, if you want to have Gen AI capabilities in your application, that's just an AI at the an API at the end, to which you reach out from OpenAI, etc. And for that, especially for a microservice application with a lot of endpoints, you need a way to manage those APIs, and in best case expose it as one API, and not like if you have 10 microservices, 10 APIs. For that, we have a solution called Spring Cloud Gateway. So at the end, it's a library to build an application gateway. And you can also really easy start. You just add this dependency and start with Spring Cloud IO, and then you define like what are my different routes. So I have them here that I can easily change them in my configuration server. You can see also this load balance annotation. So that's part of this Spring Cloud load balancer that is just integrated. And then I can define what's the endpoint from my endpoint of the gateway. And with that, that's really basic here. You can do a lot of things like authorization, rewrites, retries, also a lot of capabilities. And last but not least, authentication authorization. That's for sure an important topic. We have everything you need, more or less. So all the standards for those applications, usually OAuth is the one you implement. And everything from services that are just consuming tokens, validating them and extracting information, to also that are doing the complete flow on the front end side. And then also a Spring authorization server where you can implement it yourself for test cases also, if you don't want to rely on something like Okta, your own server. That's all in the source code, so you can have a closer look. You can see I added 2 more here on the right, like Spring Cloud Stream, Spring Cloud Function. That's something I'm using for the shipping service because it's at the end an event-driven application, and this is what they are for. So also with Spring Cloud Function, not have to rely on a specific API, or for example, AWS Lambda. That's the benefit of it, that you can really implement it in a way that you can easily switch between different function as a service providers. That's it. So that's the Spring architecture application. At the end, it's you can see a lot of components to manage, and therefore, that's a lot of effort. And in best case, you have a high abstraction platform that provides you all those features. And there are several available. So for sure from us, like Cloud Foundry with all the services, commercial services. Also on Azure, there are those components because they are also working with us together, on what's necessary to run those Java apps at the Java team of Microsoft, for example. So that's my recommendation, to always try to find the highest abstraction possible for you, where a lot of those services are easy consumable, for example, via self-service. That's it from my side. Here is the Git repository with the sample. I will also upload a slide, so maybe on Sunday when I'm at the airport, or otherwise on Monday, together with the latest state, and then you can try it out yourself, because it's designed so this version that it runs on your local computer if you have a container runtime. Thank you very much.